Hey guys, Mr. Wilson here. Today we're going to deal with compound inequalities. We have two sets of compound inequality notes. This one will focus. I guess we'll jump straight into it. A compound word is two words put together. Okay, doghouse, keyboard, basketball. Okay, compound words. Okay, then a compound inequality then is when two inequalities are put together. There are two types of compound inequalities that we'll look at in this unit. We'll talk about and inequalities and or inequalities. We'll look at and today, and we'll look at or in the next lesson. Okay, so find all the numbers that are greater than 2 and less than 9. So we want to find the numbers that are, if we're looking at these two inequalities, you see we have 2. We want to find all the numbers that are greater than 2 and less than 9. Two of them at the same time. So what I'm going to do, I'm going to say greater than 2. I'm going to say x is greater than 2. And x is less than 9. Okay. Another way of writing this is, since x is the subject of both these inequalities, I'm going to put x in the middle. Okay. I'm going to say that x is greater than 2, greater than 2. See, I kind of had to do that backwards though. And x is less than 9. Sorry. And we see a solution is still any value that makes this inequality true, or both inequalities true. Okay, has to make both inequalities true. So since there are an infinite number of solutions, we again need to graph to show all the solutions. You might say like, oh no, there's only like 6 numbers in between, but there's not. There are like infinity numbers in between. Okay, and so we'll make sure we put our numbers on our number line correctly. It does not have to go left to right, like it doesn't have to be the lower numbers to the left, so make sure you're paying attention to that. Still follow our rules with open circles and closed circles. These are both just less than and greater than, so not or equal to, so they're both open. I'm going greater than 2. I'm going less than 9. They'll meet up. This is our solution. You can do like that and say the middle line, that's fine. Or you can raise above the line and connect it, that's fine as well. Okay. Alright, so we can use compound inequalities to talk about other things like temperature. Monday's high temperature, I wish it was 74, it was like 90, was 74 degrees, and low temperature was 51. Show all the temperatures from Monday. So we're going to say, okay, well the low was 51. No, that's the low end of my inequality. The high was 74. Okay. All the temperatures in between will reach to touch that. So we'll say, well, the temperatures would have been greater than or equal to 51. Remember, since 51 was the low, it was 51 at a time. And it was less than or equal to 74. Okay, so I have my 51 low, I have my 74 high. These are both or equal to, so closing the circle. And then greater than 51, less than 74 here. Alright, so that's graphing compound inequality, and let's talk about solving and inequality. Okay, to solve and inequalities, we want to isolate the variable. That does not change. We want to get the variable by itself. However, the variable is found in the middle of two inequality symbols. The two inequality symbols create 3 sides to the inequality. Okay, so we're used to having an equation with 2 sides or inequality with 2 sides, but since there's 2, we have 3 sides. So whatever you do to the middle of the inequality, you have to do the same thing to all 3 sides. Alright, and the way that I think about this is, don't even worry about the outsides of the thing. Look at the inside and see, how can I get x by itself? As we're looking at this, we have x minus 5. Alright, I'm going to say, well, to get x by itself, I have to add 5. And then focus on making sure that you do whatever you did to the middle to the other sides of the inequality. Okay, so I'm going to add 5. Add 5. That gives me 1. That gives me x. That gives me 8. I just added 5, so nothing about my signs change. And now I have my answer. X is greater than 1 and less than or equal to 8. That's how you'd read it from the middle. Okay, and so 1, 8, it's an open circle at 1 because it's greater than, 1 is not a solution, and a closed circle at 8 because it's or equal to. Okay, and there we go, that's our solution. Backside here. Alright, we're going to solve each inequality. Again, dealing with just the middle, I'll do a couple. I'm going to leave number 4 for you guys. I'll do number 4 for the fraction. I'll leave number 3 for you guys to do. Okay, so again, I'm going to focus on the middle. Need to divide by 3. Now that I know that's what I'm doing, I'm going to divide each side by 3. So I'll have negative 4, I'll have x, I'll have negative 1. I divided by a positive number so I don't have to worry about flipping signs. Negative 4, x, negative 1. So x is greater than or equal to negative 4 and less than or equal to negative 1. I will then use my number line. Negative 4, negative 1, that's right. Okay, close circles because it's or equal to, and then connect them. All right, number 2. I want to get this by itself. The first thing I'm going to do, remember that this is kind of an understood parentheses, I'm going to multiply this middle by 4. So since I multiplied the middle by 4, I have to multiply all 3 sides by 4. 4 is a positive number, doesn't change that, so that gives me 52. That will give me 20. My next step in solving this would be to add 1 to each side. So I have negative 51, 3x, 21, and then I'll divide each side by 3. And that will give me, just write on this line since that's going to be my final step anyway, I think that's 17, negative 17, and 7. So x is greater than or equal to negative 17, closed circle there, and less than 7, open circle there, connecting the line. Like I said, I'm leaving you guys to do number 3. Number 4, I'll do because of the fraction, and I see that you guys need a little bit of extra attention with that. Okay, so subtracting 4 first. I have 10 is less than 2/3 x. 18, there we go. Alright, and now I need to get rid of this 2/3 that's with x. Remember, to do that, it means we're going to be multiplying by the reciprocal. Since I did that to one side, I have to do that to all the sides. Okay. If you want it, if it helps you out anymore to remember the multiplication rules, every number is a fraction, so I'm going to set that up that way. So I have 30 over 2. This would give me 54 over 2, and this would give me just x. Okay. All right. And I'm going to simplify that. 30 over 2 is 15. 54 over 2 is 27. 15 here. 27 here. Open circle. Open circle. Let's look at the last one. Last one, remember I'm focusing on the middle. I need to see how I'm going to get my variable by itself. I'm going to get my variable by itself first by subtracting 3. Remember that that number is positive or it would have a negative sign in front of it. So we need to do the opposite. When I subtract 3, remember this was negative 2x. It still is negative 2x. Okay, now I need to divide by negative 2. When I do that, 5x negative 4, I just divide it by a negative number. Remember our rule is that when we multiply or divide by a negative number, we have to flip the signs. Okay, we have to flip the sign. So what that means that we're going to do is we're going to change them. Flip the direction that they're going. Okay. Alright. If you run into a problem that's difficult and you're like, oh man, I really can't, one option that you can do is just to cover this up and write the problem out. Negative 7 is less than 3 minus 2x. You can do it to the other side as well. 3 minus 2x is less than or equal to 11. And what you'll be doing is you'll be going through the same steps that we just did. Divide by negative 2, divide by negative 2, divide by negative 2, divide by negative 2. And what you'll find is that you get the same answer. But if you are confused, you don't know what's happening because of you just feel like too much is happening, one strategy is just to cover up one of the inequality signs and solve that part. And then just remember that you can bring these together at the end and say, okay, well, x is less than 5 and x is greater than or equal to negative 4. Okay. So I'd much rather you do it this way, okay? But if you can't, this is an option. Okay, the graph is going to be the same. I'm going to have 5 here, negative 4 here. See how I paid attention to where they would actually go on the number line and not just where they are in my problem. Okay, negative 4 has a closed circle because x could be negative 4. 5 has an open circle because it cannot be that. X is greater than negative 4. X is less than 5. And there we go. Alright, so we just solved and inequalities. See ya.